let's modify this outbound filter here. So this filter here that we have on R4, I want it to be configured so in the outbound direction, advertise loopback 0 of R9, loopback 0 of R1, and for that use a prefix list. And advertise loopback 103, this network 103 that we have configured here, and use access list for that feature. Make sense? So what I want to do is I want to modify this outbound filter on R4 to advertise only loopbacks of R1 and R9, and for that purpose I want to use the prefix list. You can use multiple prefix lists or one prefix list, it doesn't matter. But for loopback 103, you need to use the access list. Now, let's write that filter. So we already have a filter in place. Now, I cannot have more than one route map added here, but I can add distribute lists, I can add prefix lists, I can add other stuff, but then I have to worry, what is the order of preference? What is the order in which they are processed? So now I'm going to use the route map. So let's say here that the restriction was use the outbound route map. Now, let's create that prefix list that we need. So it is going to be IP prefix list, and let's call it R4, R9, permit, and it's going to be 192.168.0.1/32, and it's going to be 0.9/32. So this prefix list will cover that. Then I'm going to have another route map entry. So this was here, let's say permit 10, and then I'm going to have permit 20, and I'm going to say match IP prefix list, match IP address, apologies, prefix list R4-R9. Okay, so let's see what happens when I apply this on R4. So if I go to my R4 now, and I say clear IP BGP star soft out, if I go to R1, show IP BGP, this is the list of routes that I'm receiving. Okay, I'm receiving this, which is what I wanted to receive, and I'm receiving this, which is what I wanted to receive, and I'm receiving this. But why am I getting these routes? Oh, they might be stale routes. You know what? Let me just clear the BGP. So I'm now hard clearing the BGP. And if I do show IP BGP, they are back in. Why are these routes back in? That is interesting. Or why is this route in? Why is this route in? Well, these are the routes that I don't want in. Well, the problem lies in my route map, because take a look at what my route map does. It says route map basically match everything, set community additive. Now, if you have a match in a route map, the processing of a route map ends at that point. That means that this entry here will never actually be touched. It will never be hit. So I do have an option here to take this and copy paste it multiple times in my route map every time I need it, or I can actually use an interesting feature of the route map, which is continue. Now, with the continue keyword, what I'm telling my iOS is, if you match this entry, instead of exiting the processing, you know what, carry on. And in this case, I'm going to have a match for these two. I'm going to add an access list later on, but for now I just want to show you this behavior. But now what's going to happen at the end, there is going to be that implicit deny. So let's see if this changes the behavior in any way. So if I go to R4 here, and if I simply add this continue keyword, let's clear the session again on R1. Okay. Maybe that was a bit too much. Let me see. 192.168. Oh, it's actually 4 and 1, not... I used the wrong one. So let me correct that, but that shouldn't be the problem. Let me just quickly correct that. So it's 4 here, and let me see. There we go, show IPExpert. Well, we still have the same problem. What did I do wrong? Let me take a look. Now there is troubleshooting. Marco now needs to troubleshoot his own mess. Show run pipe section. Let's see what I did wrong here. So I'm saying match everything, continue. And here I'm matching this address prefix. So what I need here now is actually, I need, let's see if this will help. Maybe this is not doable the way I wanted. This is the first time I'm actually doing this example. So let's do it like this. So clear IPBGP soft in. This should work. Maybe I need to just clear IPBGP star soft out. Ah, much better now. Yes, that was it. I needed to clear it. I was pretty sure this is going to work. So I just needed to clear it from R4. So now, this is what happened. So let me explain what is going on right now. So going to my notepad here, what is happening is, hopefully you can see my mouse. What is happening is we have this first route map entry, and here we are matching everything. So this route map entry will match everything. We are going to set community internet additive on all routes as required by the previous task. Then we are going to say, instead of just exiting the processing because we had a successful match, let's just continue with the processing. And here we are now hitting this match this prefix list. So if I have these two routes, actually we changed this one, so let me fix it. So if we have these two routes present, allow them, but then we are simply going to exit processing. The next route map entry, so all other routes that were actually permitted by this entry, are now being explicitly denied. So in a sense, with this solution here, we are only allowing these two routes to be advertised. And if we take a look, these are the only two routes that we are actually receiving. This route here, this is our local one. There is nothing we can do about this route, but these are the only two that are being allowed. So this takes care of the first part of the task. It takes care of this part here. Advertise the loopback of, sorry, and there was a tiny little error here, so this is not R1, it should be R4. Loopback of R9 and R4 to R1 and use the prefix list. Check. Now, loopback 103, we have to use an access list there. So going back to our notepad here, what we need to do is add a route map entry here. So R1 out, let's say permit 2030, and I'm going to say match IP address. So this needs to be an access list, so let's add that one access list. So I'm going to say access list, let's say 1 permit. What I need here is 10 0 103 0. So, and let's say, because it's /24, I want to use this wildcard mask. Okay, so here I'm going to say match IP address 1. So let me add this to our configuration. So if I add this to R4, and again, I do clear IPBGP star soft out, what I'm getting now is, oops. Okay, maybe I need to clear it again. Why did these routes suddenly leak in? This is just pretty annoying, I have to admit. This is not expected. This is not exactly what I'm expecting to see. So, oh, did I forget to add the access list? Oh yes, I forgot to add the access list. That's right. So I just copied the route map. So, oh yeah, so I'm basically matching everything. Yeah, mad cow. Okay. See, it can happen to anyone. So let's add, no, not here. Let's add the access list. Ah, very good. I was just about to declare a bug. And you see how easy it is to declare your own mistake a bug in iOS. A simple oversight. I had it here in Notepad. I typed it and I was thinking, okay, I typed out the access list. Of course it's there. But when I copied into the terminal, this was the only thing that I copied. So it basically matches everything. So let's take a look at this now. Oh, much better output now. So basically what I'm having is this network here, and I'm having this. Now, let me go to R9 and do something that I have not been asked to do. But I'm going to need it now just to show you a problem. Why this solution that I just implemented is actually an incorrect solution. So I'm going to go to R9. So I have not been asked to do this, but this is just a test. So I'm going to go here and I'm going to go to router BGP 900 address family IPv4, and I'm going to say redistribute static. Now there are no static routes yet, but I'm just going to add one. So I'm going to say IP route 10.0.103.128. So I'm going to create a null route for 10.0.103.128/25. Now, if I do show IPBGP, this route is now being injected into our BGP. If I go to R4, if I do show IPBGP, I'm now seeing this route in my BGP table. If I go to R1, show IPBGP, take a look at this. This route now made it through. Now, my task here was very explicit. Advertise loopback of R9, loopback of R4, and loopback of 103. Use the prefix list here and use the access list here. Now, does this route, the highlighted route, match any of those routes that I'm supposed to match? No, it doesn't. This is the route that was installed there just for testing purposes, and it actually breaks the requirements. The problem is here in this access list. So with this access list, what I'm telling my routers is advertise this network that matches this matching pattern, that matches this wildcard mask. And here I'm telling it, because all the bits in the first 3 octets are 0, that means that the first 3 octets must match exactly. But the 4th octet I don't care about. Why? Because all the bits in the 4th octet are set to 1. So whatever is here in the 4th octet, I don't care about. Okay, so I know how to fix this. Instead of using this access list, I'm going to use this access list. So now, this network here must match exactly. Let's give this a try. So I'm going to go to R4, going to add this access list, and instead of using access list 1, I'm going to use access list 2 in this route map. So let's clear the BGP process. And let's go to R1, and if I do show IPBGP, success. That /25 route is now gone. Okay, let me try one more thing. So on R4 now, or actually, let's do it on R1. I'm going to add one more static route. let's say, well, this is going to be a tricky one, because 103 here, how can I show you this? I chose a completely wrong network for this. I needed something that is even numbered. Because now what I'm trying to do is I need a supernet of this. I need something that is larger than /24, but with 103 I cannot do it. So for this particular case, it works. Let's add another task. I want to add another loopback here, loopback 104 on R9, and I want this to be 10.0.1040/24, and I want this to be allowed as well. There are no restrictions on this loopback, simply just advertise it. So for 103, this access list here worked. So for loopback 104, use ACL as well. Okay, so let me add that. So on R9, interface loopback 104, IP address 10.0.1040. Actually, I need to give it an IP address. Sorry about that. But it's good that I made this mistake because I can actually use this in a second. So router BGP 900, address family IPv4, IPv4 network. I can use this now. There we go. So if I go to R4, show IP BGP, I should be getting this /24, but right now it is not being advertised because we don't have the route map entry for it. So let's fix that. Let's add entry 40. And here, let's say match IP address 10. So I'm going to add access list 10, permit 10.0.1040. We learned from previous mistake, so I'm just going to add it like this. So this access list goes on R4, and this route map entry 40 goes in here. Clear IP BGP star soft out. If I go to R1, there is our network 104. Success. Let me go back to R9. And now what I'm going to do is I'm going to say IP route. Actually, let me be even more creative. So router BGP 900, address family IPv4. I'm going to say aggregate address /16. Actually, not /16, can't do that. Let's do /22. So now if I do show IP BGP, I will see that here I have two 104 networks. One is 10.0.1040/24, and the other one is 10.0.1040/22. So these parts of the network, and this is why I needed an even numbered one, are exactly the same. So if I go to R4, if I do show IP BGP, here are my two networks. One is /24, the other one is /22. If I go to R1, here are my two networks. /24, which I'm supposed to have in my table, and 104/22, which I'm not supposed to have. So how do I fix this problem? Mind you, I have to use an access list. Now, if this was a requirement to use a prefix list here, this would have been just fine. I would have used the prefix list /24 and I'm done. But with access list, what's the problem here? Well, the problem is that with access list, with the standard access list, you cannot match the net mask. As we have seen here, this is not an inverted net mask. This basically tells me which bits from the actual network part I care about, but it doesn't talk about the prefix length. I can match the prefix or the range of prefixes or even odd prefixes, those that have bit number 6 set or don't set. This is what the net wildcard mask does. But what I cannot do, I cannot match the prefix length. I cannot say that this is /24. Not with a standard access list. But when used in context of BGP filters, and there is only one other case, so let me emphasize this. So what's coming up next is available only when you are using extended access lists for BGP filtering and for ISIS level 2 to level 1 route leaking. In no other cases can you use access lists in this fashion. So this feature that I'm going to show you now works only, as far as you are concerned, for BGP filtering. So that said, oh, did I mention that this works only in BGP? This thing that's coming up that works only in BGP is a special feature of extended access lists, where you can use the destination part. So what is coming up now, this is the source address. So what we usually have here is the source address and source mask. What is coming up next is usually destination address and destination wildcard mask. So you can use the destination part to actually match the net mask. So when used for BGP filtering, whatever is the source part of IP address is going to match against the prefix. Whatever is the destination part will be matched against the net mask. Now, I'm using all zeros here because my net mask must be /24. But I can do something like this, in which case I'm telling my router that it should match 10.0.1040 exactly, and then the net mask should be a subnet of that /24. Why? Because these bits here need to match exactly, but I don't care what's in the last prefix. So if I use this, I'm going to have a very unusual effect. Let me show you that. So instead of access list 10, here I'm going to use access list 100. And let me paste this access list 100 on R4. And let me paste this in and then clear IPBGP star soft out. So if I go to R1, what I'm having now is my /24 network, which is exactly what I wanted. But take a look at this. I'm going to go to R9 and I'm going to say IP route 10.0.104.128. Okay, let's see if it was already advertised. It might take a little bit. There it is, 104.128. Oh, sorry, of course this won't work. So this route now, even though, oh, okay, case in point. So this route now, 104.128/25, we can see that it is now on R4, but if I take a look at R1, it's not actually making it in the routing table. Why? And this is expected, I just wasn't thinking straight. Because this part here needs to match exactly. So I need to have this 0 here. This 0 must match exactly. But if I go to R9 and I create, for example, this route, so show IPBGP, so this route now is /25, but it has 0 here. When I go to R1, this route has made it through. Why did it make through? Because I'm telling this router that this part here must match exactly, but I don't care what's in the last octet of the mask. So it could be 10.0.104/24/25/26/27 up to /32. That's fine, but if I have 128 here, that won't make it through. So if I want this to be truly all subnets of that 1/24, I can do something like this. So let's try this access list here. So if I paste this in and use access list 101, now what I will have in my R1, you will see that I have all the subnets of 104 network. But this doesn't solve my task. My task says that one network exactly. So to make that work, let's use the access list 104. This needs to match exactly, and this needs to match exactly. So this will be what goes in R4 here, and the route map needs to be 104. So now, if I clear the routes, what I will have in my R1 is just 104/24. So if you are asked to use access lists for BGP filtering, this is something that you should know how to do. And I know that this may look like very, very complex and very, very unusual. Trust me when I tell you, once you get the logic of how this works, once you have actually watched this maybe explanation 1 or 2 more times, you will realize that using access lists for BGP filtering is actually more powerful than using prefix lists, because you can actually do more stuff with access lists than you can with prefix lists. The question I have is, if in the lab we come up with the situation in which there is a problem in the order in which the route map is being processed, is it better to use the continue statement or to actually reorder the route map? My recommendation is reorder the route map. Continue statement is really just a gimmick that has very limited use. I've shown it to you just so you can see how you can, if you carefully plan the use of it, you can use it. But my recommendation is, unless you're restricted from reordering the route map and you think that's the problem, just reorder the route map. You are going to be far more in control with that than you would be using the continue statement.